In this video, we're going to cover question number 6 from 2017. This is a non-calculator problem. You should have already done this on your own, so you should be grading yourself based on what you see here. So with that said, let's go ahead and get started. Number 6, it says let f be the function defined by f of x given by that equation. We also have g and h given in the table and the graph above. We also have g prime there as well. And for part A, it says find the slope of the line tangent to the graph of f at x equals pi. Well, that's a pretty easy problem. Finding the slope of the tangent line just means find the derivative of f at x equals pi. So when we take the derivative of f of x here, the derivative of cosine of 2x, you need to make sure you use the chain rule properly. So the derivative of a cosine is negative sine. So it'd be negative sine of 2x and then times 2. And then the derivative of e to the sine of x, again you got to use the chain rule. So the derivative of e to the anything is e to the anything, and then times the derivative of that exponent, so times cosine of x. And then I just rewrote it in a little bit different order. But that's the derivative function, and now we just need to plug in pi there. And so we end up with negative 2 sine of 2 pi plus cosine of pi times e to the sine of pi. And then simplifying that, the sine of 2 pi is 0. The cosine of pi is negative 1. And then sine of pi is 0, so e to the 0 is going to be 1 there. And then ultimately that simplifies to negative 1. As far as points go, you're going to get a point for figuring out what f prime of x is, so a point for this line, and then a point for your final answer of negative 1. Okay, for part B, it says let k be the function defined by k of x equals h of f of x, find k prime of pi. Well, that's, again, pretty straightforward. We're just looking for k prime, so we have to take the derivative. Well, the derivative of this, we'll be using the chain rule again. So the derivative of h is h prime of f of x, and then times the derivative of the inside, so that would be times f prime of x. So we have our derivative function. Now we just need to plug in pi. And so we end up with h prime of f of pi times f prime of pi. So we have to figure out what f of pi is. Well, f of pi is going to be a result of plugging pi into our equation here. So just doing that off to the side, we've got cosine of 2 pi plus e to the sine of pi. That simplifies to 1 plus e to the 0, or just 2. And then we knew from the previous part A that f prime of pi is negative 1. So we can take that and plug it in to our k prime function. And so now we have h prime of 2 and then times negative 1. So now we have to figure out what h prime of 2 is. So that's looking at this chart here. Since this is the graph of h and we want the value of h prime, we have to look at the slope of this curve, or the slope of this function at 2. So this is just a matter of finding the slope of that line, which is negative 1/3. And then times negative 1 gives you 1/3. Points on this, you're going to get 1 point for figuring out what k prime of x is, and 1 point for figuring out the value of k prime of pi, so your final answer. One thing I want to note here, that if you got part A wrong, so if you had f prime of pi equals something else from part A, but you use that value and plug that in right here, or right here, if you use the value, whatever value you got from part A, and you plugged it in and you got whatever your answer is based on that, based on what you put there, if it's correct, you would still get the full credit for this part, because the AP readers read with your work. And so they're not going to ding you here. They're not going to ding you here for having a wrong answer if it's a result of having a wrong answer on part A. So keep that in mind. Now for part C, it says let m be the function defined by m of x equals g of negative 2x times h of x. What is the derivative of m at x equals 2? So again, it's another derivative problem. So we need to take the derivative of m, and I notice that I have a chain rule right here because I got negative 2x inside of the g, and then I also have a product here, so I'm going to have to apply the product rule. So the derivative of the first thing is going to be g prime of negative 2x times negative 2, and then times the second thing, so times h of x. And then the derivative of the second thing, which is h prime, times the first thing. So it would be plus h prime times g of negative 2x. And then we have to plug in 2 to our x values and evaluate from there. So I kind of skipped a quick step here. I plugged in 2, so negative 2 times 2 is negative 4, just to make it a little quicker. So we need to figure out what g prime of negative 4 is. That's given in our table. G prime of negative 4 is negative 1, so that can go here. H of 2 is just the value of the function of h at 2. Now that might look a little weird to you, but you can see that the slope is negative 1. So that means we went down 1/3. Sorry, the slope is negative 1/3, so we went down 1/3 over 1, down another third over 1. So h of negative 2 is actually negative 2/3. And then plugging that all in, so you have negative 2 times negative 1 times negative 2/3, so that's for the first part. And then we need h prime of negative 2, sorry, h prime of 2, which is again negative 1/3. And then we need g of negative 4. G of negative 4 is going to be 5. And then from there we just simplify this. We end up with negative 4/3 minus 5/3. That's negative 9 over 3 or negative 3. Points on this, you're going to get 2 points for m prime of x and 1 point for your final answer. So I believe that you're going to get 1 point in the m prime of x if you showed that there's a product rule going on there, so if you did the product rule correctly, and then 1 point for probably using the chain rule correctly. So basically 1 point if you use the product rule, and then 1 point if you got your total m prime of x here, and then 1 point for your final answer. All right, for part D, let's see here, for part D, it says, is there a number c in the closed interval negative 5 to negative 3 such that f prime of negative 4, the f prime of c is negative 4. Now, this is one of those questions where it's asking, is there a time or is there a x value or a c value that produces some truth? And that gives us, it makes us think of all of our theorems, the mean value theorem, extreme value theorem, intermediate value theorem. Now, one thing I want to point out, that if it was asking for is there a point where g of c is negative 4? Well, if we're looking at g and we're asking about g, that would be the intermediate value theorem. If we're looking at g prime and asking about g prime, that would again be the intermediate value theorem because you're talking about just the values of the function. But since we're asking about g prime and we're given g and g prime, we can approach it both ways. We can approach it, or we could try to approach it with 2 different methods. If I want to use the intermediate value theorem to show that g prime of c is going to be negative 4 for some value between negative 5 and negative 3, well, what I notice here is that at g of negative 5, I have a value of negative 3, and then at g of negative 3, I have a value of 4. So by the intermediate value theorem, if this function is continuous, and it is, then g prime and all that, will equal every value between negative 3 and 4. Well, in our problem, it's asking whether we have g prime of c equaling negative 4. Well, negative 4 is not in the domain, or sorry, not in the range of negative 3 to 4. So we can't use the intermediate value theorem here to justify why. So if we look at our g function and we are trying to show something about g prime, then that's going to be the mean value theorem. So we have to find the average slope between negative 5 and negative 3. So the slope between negative 5 and negative 3 is going to be 2 minus 10 over negative 3 minus negative 5. And then that simplifies to negative 4. So we can say that since the average slope is equal to negative 4 over this interval, then the derivative will equal negative 4 at some point in that interval, as long as the hypotheses for the mean value theorem are true? Well, it says that g is differentiable over, well, the entire interval looks like it's a differentiable function, which means it's differentiable from -5 to -3, which implies that it's continuous over that same closed interval, which means that the mean value theorem will apply. And then as a result of that, we'd say since the average slope over the interval -5 to -3 is -4, then there will be a point, there will be a C value that exists between -5 and -3 where the derivative is equal to -4. So point values on this, you're going to get 1 point for the difference quotient. In other words, you're going to get 1 point for finding the slope in that interval and showing that it's -4. And then you're going to get 1 point for the answer with the mean value theorem as your justification. Again, you do not get the point for that justification unless you point out that the function is differentiable and continuous, therefore the mean value theorem applies. Okay, you have to make sure that the requirements for the mean value theorem are met before you use the mean value theorem. Anyway, so go ahead and grade yourself on that. And if you have any questions, feel free to ask me. The next problem that you're going to work on is going to be a quiz, and that quiz is going to be number 6 from 2016, and that is a non-calculator problem. You'll notice the calculus basics type tend to be non-calculator because it's a lot of just what is the derivative, what is the integral, what is the derivative. So it's testing your ability to take the derivatives and the integrals here. So go ahead and do this FRQ on your own, set a timer for 12 minutes, and then come back and watch the next video to see how you did.